In this video, we're going to look at the homework from page 329, 95 through 106, and we're going to be reviewing the fundamental theorem of calculus part 2. In this video, I will be using the slate, which sometimes is not always the most friendly when it comes to writing. So I'm going to start out by reviewing the fundamental theorem of calculus part 2, but I'm going to do some typing. So remember that the fundamental theorem of calculus part 2 is used for the fundamental theorem of calculus is used for finding the derivative of a definite integral. Now it's very important that you remember when you're using the fundamental theorem of calculus part 2. It is simply used when you're finding the derivative of a definite integral. So for example, if you take a look, let me grab my pen here. Come on, where's the mouse? Here we are. So if you take a look, for example, at number 95. In number 95, and in all of these, f of x is a definite integral. In this case, the lower bound is -2 and the upper bound is x, and what they're asking us to find in the directions is the first derivative. So we're taking the derivative of a definite integral. Now if you think back to the video that you looked at, when you're finding the derivative of a definite integral, there are basically 3 steps to do that, and here are the 3 steps. Number 1, take out the t. Often the dummy variable, it's called a dummy variable on the integrand. Remember, the integrand is this part that I'm waving over here. The integrand is the function that you're actually going to find the antiderivative of. But we know that the shortcut, the fundamental theorem of calculus part 2, we don't actually have to find the antiderivative because we have a shortcut. So the first step of the fundamental theorem of calculus is to take out the t, take out that dummy variable. The second step is to put in the new function. Now the new function, let me grab my pen again, the new function is the variable expression in the upper bound. In this first section, you'll see that the upper bound is always the variable of x. But if you look down in here in the next part, the upper bound is x plus 2, the upper bound is sine of x. So that's what we mean when we say put in the new function. We're putting in that upper bound that is a variable expression. And then the third part is to multiply by the derivative of the new function. Alright, so those are the 3 steps of using the fundamental theorem of calculus part 2. Number 1, take out the t. Number 2, put in the new function. And number 3, multiply by the derivative of the new function. I'm going to move this up here out of my way, see if I can keep it up here. So give me 1 second to take care of that. Okay. And then I'm going to keep this at the top. Get rid of all this mess that I've created over here. And then I'm going to pick up the slate and actually do some of the homework problems. Alright, so let me get my slate here and change this back to pen, and I'm going to go with blue writing with the pen. Alright, so I have the slate now, and I'm going to start with number 95. Alright, now my slate is taking over. So in number 95, let me pull this down just a little bit. Alright, so those are our 3 steps. So in 95, we're trying to find the first derivative. So we're finding the derivative of a definite integral. So the first derivative of big F, step number 1 is to take out the t. My function is t squared minus 2t, so I'm going to have t squared minus 2t. That's step number 1. Take out the t. Step number 2 is to put in the new function. In this case, the new function is x. I'm going to put an x where the t was and an x where the t was. So the first derivative is x squared minus 2x. Remember, we don't have to take the antiderivative and then go back and take the derivative. This is simply a shortcut for finding the derivative of a definite integral. Also, notice that the lower bound is a constant, and if we take the derivative of a constant, we get 0. So it's important in each of these cases to make sure that the lower bound is actually a constant. All right, so that's number 95. Moving on to number 96. And in the directions in your homework were to take the second derivative for the even problem, so I'll do that as well. So in number 96, we're going to find the first derivative. The shortcut for finding the derivative of a definite integral, notice that the lower bound is a constant, so we're good there, and the upper bound is a variable expression, so we're good there. So we're going to take out the t, so we have t. Let's get rid of that. So we have t squared over t squared plus 1. That's the first step. Second step, put in the new function. The new function is x, and everywhere that there's a t, we're going to put in that x. And then the third step is to multiply by the derivative of the new function. In this case, our new function is x, and the derivative of x is 1, and that takes care of the chain rule. We don't really have to worry about that when the variable is just x. So if I clean that up, I have x squared over x squared plus 1. Right, that's the first derivative. So for the evens, we're also supposed to find the second derivative. So the second derivative is going to require the quotient rule. So we have down d up 2x minus up x squared, d down 2x all over down. So x squared plus 1 quantity squared. Cleaning that up, when I distribute the 2x, that'll give me 2x cubed plus 2x minus, poopy dogs. Here, let's just do that over again. So we had 2x cubed plus 2x minus x, we're multiplying there. So that's going to be, go away, 2x cubed over x squared plus 1 squared, and the 2x cubed and the 2x cubed divides out, and you end up with 2x over x squared plus 1 quantity squared. Alright, that's 96. I have a feeling I may not do all of these because I'm going to run out of patience with using the slate, but we'll see how far I can go before I jump down to the next section. Hopefully you're getting the idea that it's just 3 steps. One of the main things you need to remember is that when do you use the fundamental theorem of calculus part 2? When you're trying to find the derivative of a definite integral. Right, there's my pen. And now we're going to go back up to number 97. 97, we're finding the first derivative again. And in 97, our lower bound is a -1. The upper bound is x. So we're going to, there's my square root, take out the t, so t to the 4th power plus 1. Step number 2, change colors here. Put in the new function, which is x, and step number 3, multiply by the derivative of the new function, and the derivative of x is 1, so the derivative is just the square root of x to the 4th plus 1, and we don't have to find the second derivative here. Let's go to number 99. So let's clear some annotations here and take a look at number 99. I'm going to skip number 98. In number 99, we're finding the first derivative. There are 3 steps to finding the derivative of a definite integral. Number 1, we're going to take out the t, so we have t multiplied by cosine of t. I lost my pen here. There you are. The step number 2 is to put in the new function, and in this case the new function is x, so we're going to put an x everywhere that we had a t, and then lastly multiply by the derivative of the new function, which is just 1. So the first derivative is x cosine x. Alright, let's jump to the next section. And let's take a look at number, definitely look at number 101, because there is a variable expression in the lower bound. So if you look over here, the lower bound is an x, and the upper bound is also a variable expression. So we need to talk about what to do in that particular case. Alright, so here we go. When there is a variable expression in the upper bound and the lower bound, we're going to do that process twice. So we're going to take out the t, put in the new function, and multiply by the derivative of the new function, but we're going to do it once for the lower bound, and we're going to do it once for the upper bound. So the first derivative, alright, so we're going to start with the x. Number 1, take out the t, so we have 4, take out the t, there it is, plus 1. And now we think about the fundamental theorem of calculus part 1, where we have the upper bound minus the lower bound, so there's the plus 1, minus, and then we're going to do it again, that minus is upper bound minus lower bound, take out the t again, make room for the new function. Alright, so there is the expression for the upper bound, there is the expression for the lower bound. So we're going to put in the upper bound of x plus 2, squish it in there, and then we're going to put in the lower bound of x. Now when we multiply by the derivative of the new function, in both of these cases the derivative of x plus 2 is 1, and the derivative of x is also 1, so that's not going to really have a big impact. So when I clean that up by distributing, I'll get 4x plus 8 plus 1 minus 4x, should have had that in parentheses because that negative has to be distributed, minus 1, 4x subtracts out with 4x, and so we have 8 plus 1 is 9, 9 minus 1 is 8. So the first derivative in this case simply turns out to be 8. Alright, let's go ahead and look at number 102 for sure. Yeah, 102 and 103 for sure, and then we'll see how many more problems I'm going to do from there. While I'm erasing, I want to remind you to think back, what is it that we're doing? We're finding the derivative of a definite integral. And the fundamental theorem of calculus part 2 is a shortcut to finding the derivative of a definite integral. So in other words, we don't have to find the antiderivative and then go back and find the derivative. This is the shortcut, and the shortcut is 3 easy steps. All right, so we're going to take a look at 102. Our lower bound is negative x, and our upper bound is positive x. So here we go. To find the first derivative, when we want to find the derivative of a definite integral, the first thing we do is we take out the t. So we have an upper bound that we're going to take care of. So there's t to the third minus a lower bound we're going to take care of. Remember, this is what happens when you have an upper bound and a lower bound. So we're going to take out the t. We're going to put in the new function. So the x goes in here. We're going to upper bound minus the lower bound. We're going to put the lower bound in here, negative x. And so we get, when we clean up, x cubed minus negative makes plus x cubed, which is 2x cubed. That's the first derivative. The second derivative, that's easy. By the power rule, we get 6x squared. Definitely want to do number 103 because the upper bound is sine x, and then I want to look at 105, and I think I'm going to stop after that. That gives you enough to hopefully figure out what's going on here. So let's take a look at number 103. Number 103, our lower bound is 0, and our upper bound is the function sine x. To find the derivative of a definite integral, step number 1 is to take out the t, so f prime of x, take out the t. I'm going to write this as a power of 1/2. Put in the new function. In this case, the new function is sine x. Alright, now this is where that chain rule becomes very important. The third step, multiply by the derivative of the new function. The derivative of sine x is cosine x. So when we clean that up, we can put the radical back on and make that the square root of sine x multiplied by cosine x. This is one of the first cases where we've seen that third step become very important, because the derivative of the new function is not just 1 like it has been in every other case. So pay attention to that. All right, and then lastly, let's take a look at number 105. Let me get rid of my work here and grab my pen. In number 105, we're finding the first derivative. We're finding the derivative of a definite integral. When we find the derivative of a definite integral, our lower bound here is 0, and our upper bound is x cubed. So step number 1 is to take out the t. So we have sine of, it used to be a t, and it's squared. So there's to take out the t. Second step is to put in the new function. Now remember, this time the new function is x cubed. So I'm going to put x cubed inside. And step number 3 is to multiply by the derivative of the new function. I'm multiplying by the derivative of x cubed, which is 3. Oh, I'm doing so nicely here. So the new function is in blue, and the derivative of x cubed is 3x squared. That's the derivative of the new function. When I clean that up, I get sine x to the 6th. Remember, when you have a power to a power, you multiply. Multiplied by 3x squared, and I'm going to put that 3x squared in front to make it 3x squared sine x to the 6th. That is the first derivative of that definite integral. Let's go ahead and do 106, because in that one we're supposed to find a second derivative. So let me get rid of this, get rid of it faster this way. Back to pen. So we're going to look at 106. This is the last one that I'm going to look at. We're finding the derivative of a definite integral. So Step number 1 is to take out the t. In this case, the t is a theta. So sine of theta, take out that theta, squared, take out the t. Step number 1. Step number 2, put in the new function, and the new function is x squared. Step number 3 is to multiply by the derivative of the new function. The new function is the x squared. The derivative of x squared is 2x. So cleaning that up, I get, I'm going to put my, stupid pen. Alright, so cleaning that up, I'm going to put my 2x in front. So I have 2x sine x to the 4th power. Power to a power you multiply. Now I'm going to find the second derivative. And so when I'm finding the second derivative, I'm going to need the product rule as well as the chain rule. So this is my first function and this is my second function. So I have the first, 2x, times the derivative of the second. Now pay attention when I take the derivative of sine x to the 4th. It's a chain rule. The derivative of the outside is sine. The derivative of sine is cosine of the angle. Leave the angle alone. Multiplied by the derivative of the inside, or the derivative of the angle, which is 4x cubed. Alright, so that was the first times the derivative of the second plus the second sine x to the 4th times the derivative of the first. So in cleaning that up, I will get 2x multiplied by 4x cubed, which will give me 8x to the 4th, cosine x to the 4th, plus 2 sine x to the 4th. Hope this has been helpful for you. Hope you have paid attention to the Fundamental Theorem of Calculus Part 2. Bring any questions that you have with you to class, because we'll have a lot to cover when we get back.